Metallic bonds are the type of bonds used by metals, hence why they're called metallic bonds. They're different from the other bonds we've seen because unlike having a single set of atoms forming a single molecule, the, they come in large numbers. What you end up having is a bunch of protons and then just within all of the empty spaces between the protons, just electrons constantly bouncing from proton to proton. And and this arrangement basically ends up to make it hard to draw a fine distinction on where an individual molecule is, and it cannot be represented with a Lewis diagram. So what we think about here is that this is the like it's the electron field basically, and within it we can we this provides a lot of interesting properties. For instance, conductivity, specifically of electricity and heat. Electricity is when we have electrons flowing through the material, and when you have so much empty space and so little bonds, but only bonded as an entire compound, it's fairly trivial just to take an electron and just have it go through the path of the metal because it just blends in. It unbonds as seamlessly as it bonds. As well, we can do the same thing as heat, because heat is when the electrons are moving faster, so instead of going slowly, they're going quickly, and the reason we can do this is because when you have so many atoms that aren't really bonded to so many electrons not bonded to any specific atom, it's easy to have them go a completely different speed than normal, so that also helps. They have really high melting points, however, because there are so while they're not attached on a very attached on a molecule by molecule basis, as an entire compound, as this whole entire thing, there's a very strong attachment, and it takes a lot of energy to break apart every single molecule into a separate part. And so so that gives to their high melting and boiling points. And those are the main properties of metallic bonds, and and these bonds form in metals, which are generally going to be the everything that occupies a D block.